In this part of physics, we are going to talk about nuclear physics. And the point that we are going to focus on is the nucleus and the atom, and what is related to atomic mass and atomic number and isotopes. And we'll discuss what are nuclear reactions and types of nuclear reactions and radioactive decays and the types of nuclear radiation such as beta, gamma, alpha, and the differences between them. And we'll talk about the half-life of radioactive elements. Okay, for the first point now, as we know, the atoms of elements, they contain here nucleus, and around the nucleus there are what? Shells. On the nucleus, as we know, there are protons that are positive and neutrons that they are what? Neutral. And around the nucleus, there are electrons that are rotating on shells. And we know that protons are positive and electrons are negative. And based on that, we have two main things. We have atomic number and we have atomic mass. Okay, atomic number of any element, it represents number of electrons, or number of what? Of protons. Why? Because they are the same in neutral atoms. Number of protons equal number of electrons. So when I tell you what is the atomic number, you're going to say it's number of protons or number of electrons because they have the same number. So either it is number of electrons or number of protons is the same. Okay, what about atomic mass? Atomic mass, it is number of protons plus number of what? Of neutrons. So that means it is the number of particles inside the nucleus. What is inside the nucleus? Protons and neutrons. So this is the atomic mass, and it represents the mass of the atom. So the mass of the atom, mainly, it's the mass of the nucleus. So on the mass, or we calculate the mass of an atom, we don't calculate the mass of electrons because they are very light compared to how heavy protons and neutrons are. So that means just we said to calculate the mass, just we add number of protons plus number of neutrons, then we get the atomic mass. Okay, how these ones are written in an equation. So when we have an element that is element X, for example, now, we should write it with two numbers, a number up, like for example 20, and a number here that is what? 15. So the number that is here, it represents the atomic mass or number. So the least, the number that is less, it represents atomic number. So this one, it represents atomic what? Number. While this number here, it represents atomic mass. Okay, what is atomic number now? So if I ask you about this element now, what is the atomic mass? What is the atomic number? What is number of protons? What is number of neutrons and electrons? So you're going to say that atomic mass, it equals, as we said, number of protons and number of protons, and it represents the number that is up, which is what? 20. So you write here what? 20. Okay, what is atomic number then? Atomic number. So atomic number here is the number that is written down here, and it represents what? 15. And 15 as atomic number, it represents number of protons or number of electrons. Okay, now if we keep then writing what is the number of protons, number of protons is the same like number of atomic what? Number. So that means it is what? 15. Okay, what about electrons? Also electrons, it equals what? Same atomic number, which is what? 15. Okay, what about neutrons? Neutrons usually, as we know here, that protons and neutrons, these two, they represent what? The atomic mass. So the atomic mass now is 20 and number of protons is 15. So what is left now to 20? What is left is number of neutrons. So number of neutrons is what? Is 5. Or to find number of neutrons, you subtract the number that is up, which is atomic mass, minus atomic number, and here you get what are number of neutrons. So I hope now we understand what atomic number represents, and we said it represents number of electrons or protons, since they are the same in neutral atom. And we understand what is atomic mass, and we said mass means the mass of the nucleus. That means mass of protons plus neutrons. And you understand that when we write an element, we can write it in this way with mentioning the mass number, which is atomic mass, and atomic number. And the number that is up is the atomic mass, and it's usually greater or equal to the atomic number. And the number down here, it is atomic number. An atomic number, it represents number of protons, or number of protons, as we said, protons or electrons. So 15 can be 4 protons and 4 electrons. And number of neutrons is atomic mass, which is 20 minus the atomic number, which is 5, and it represents the number of particles that we add them plus the protons. We get what? We get 20. Okay, now we ask just a question. Are all atoms the same? Atoms of elements, are they the same? No. Atoms of an element to another element are different. In what? They are different in atomic mass and atomic number. So mainly you're going to focus on atomic number here in differentiation between the atoms of two elements. So you have atom of oxygen and an atom of aluminum. Are they the same number of protons, electrons? No, they are not the same. If they are different elements, that means their atoms are different. Mainly, different elements, they have different atoms in atomic number. That means number of electrons and protons. 4 atoms of different elements, they'll be what? They'll be different. Good. What about if we are talking about the same element? If we are talking about the same element, will all the atoms be the same? For the same element, for example, like element of aluminum or oxygen or hydrogen. For example, the element here, what? Hydrogen. Hydrogen now, are all the atoms of hydrogen anywhere are the same? Okay, what do you need to remember is, since it is the same element, so its atoms are the same in atomic number. That means number of electrons and number of protons, yes, they are the same. But atomic mass can be different. And when the atomic mass is different from an atom to another for the same element, that means what is different is just the number of neutrons. So number of protons, number of electrons of all the atoms of the same element are the same, but sometimes we find what? A change in number of neutrons, and these ones we call them what? Isotopes. Okay, like for example, hydrogen, we have here 1 and we have here 1, and we have another atom of hydrogen that here 1 and here is what? 2. What does that mean? That means here the atomic number, as you see, is 1, which is number of protons and number of electrons, and here the same number of electrons and protons are the same, is still 1, but here now it is 1. That means here it has no neutrons, and this one is, as you know, this one is atomic mass, which is protons plus neutrons. So if protons, as we said here, 1, so here it's number of protons and there is no neutrons. And at this case, here the atomic mass is 2, so that means protons plus neutrons are 2. Since 1 is the proton, so that means 1 will be for the neutron. So as you see, 2 atoms for the same element, which is hydrogen, but we have difference in number of neutrons, and these elements that they are different and the same in number of neutrons, and they are equal number of electrons and protons, we call them what? Isotopes. So elements have isotopes that are different in what? In number of neutrons. Okay. If we move to the next point, which is nuclear reaction, we know that we have 2 types of reactions, either nuclear reaction or chemical reaction. Okay, what's the difference between chemical reaction and nuclear reaction? On chemical reaction, the change is only for the valence of electrons. So that means, as we know, this is the nucleus, and around it here shells, and on the shells there are what? There are electrons. So that means chemical reactions, when atoms or elements react with others or with other compounds or other elements, that means they are going to lose electrons or to gain electrons or to share electrons. So that means chemical reaction mainly depends on gaining, losing, sharing of electrons. That means the nucleus that is here, is not related to what? Chemical reaction. So all the chemical reactions, nucleus and what is the inside the nucleus is not mentioned and is not related to chemical reactions. Okay, what about nuclear reactions? Nuclear reactions now, it deals exactly to what happens for the nucleus. So what happens to the nucleus? That means in nuclear reaction, there is a change in the nucleus itself. So that means number of protons and neutrons, they are changed in what? In nuclear reaction. That's why we call it nuclear, from the word nucleus, by the way. So that means it is related mainly to the change in the nucleus, while here we said the change is only in the electrons around the nucleus. Okay, what types of nuclear reactions? We have mainly 3 types of nuclear reactions. Okay, one of them is nuclear fission. Okay, what is nuclear fission here? Nuclear fission, when we have a big nucleus here, and it gets split into smaller 2. So that means this is now type, I'm talking about the nucleus, right? We are talking about nuclei. So if we have a big nucleus and it gets split into 2 smaller ones, this one we call it nuclear what? Fission. And the second one we have called it nuclear what? Fusion. What is nuclear fusion? Nuclear fusion is the opposite. If I have 2 smaller nuclei, then they reacted to find what? A big nucleus. In this case, we call it nuclear what? Fusion. And we need a lot of energy, or these reactions, they give a lot of energy, huge energy. It can destroy places, cities, I mean, for wide areas. Okay, what about the third nuclear fission? It is a nuclear reaction. It is radioactive what? Decay. So what is radioactive decay? Radioactive decay means when a radioactive nucleus or element, it emits rays. It emits what? Rays, in order to get higher stability for its nucleus. And for these ones now, radioactive decays, what it emits usually, the radiations that will be as a result of radioactive decay will be either helium, which is beta, which is alpha, or it's going to be beta or gamma. So that means 3 main radiations we'll get from what? Radioactive decay. Okay, what's the difference now between them? Okay, alpha is positive. This is number 1. And it can be donated as helium. That means it is similar to helium nucleus. The helium nucleus, as we know, it has 2 protons and 4 atomic mass. So that means 2 protons and 2 neutrons. So that means the alpha is positive and it can be denoted as here. And second one is beta, and beta is similar to an electron. And we know that the electron has 0 atomic mass and has also here, we can write it like -1, where it is negative for the atomic number. Okay, third one here, and it is also what here? It is negative. It is what? Negative. Okay, what about gamma? Gamma, it's not positive, it's neutral. It's neutral, that means it's not positive and it's not negative. And when there is gamma decay, they will not be changed in the number of atomic mass, which is number of protons and neutrons inside the nucleus, but they'll be changed in the energy inside it. There'll be redistribution of the energy inside the nucleus. Okay, here now, if we have, for example, now an element, radioactive element X, but before that, we need just to have an idea that just as we know, we have protons and we have neutrons and we have what? Electrons. Proton, as you know, proton is calculated as an atomic number and atomic mass. So that means proton has atomic number 1 and has atomic mass 1. So you write P like 1, 1. Okay, what about neutron? Neutron, as we know, it's not calculated in atomic number. So that means it has what? 0 atomic number, but it is calculated in mass. So that means it has atomic mass 0. Okay, what about electron? Electron, it has 0 atomic mass, and it has -1 here for the atomic number. Okay, now based on that, here, if we have now an element, radioactive element, it has, for example, here a number 10 and here a number 6. For example, we said just we give numbers to understand how the calculations. Okay, if this element emits alpha, that means when it emits alpha, that means it will emit what? Helium nucleus. That means it will emit what? He, which is helium, and here is 4 and here is what? 2. And in this case now, when this element, which is X, when it emits alpha, that means the nucleus of the element X will be changed into different nucleus. That means it will be different into new element. As we mentioned in the beginning, that atoms of different elements are different in number of atomic number. That means number of electrons and number of protons. So that means in nuclear reactions, the nucleus is changed. That means the atomic number and atomic mass is changed. When the nucleus is changed, that means the element itself will be changed into new element. So that means in nuclear reactions, we can change a nucleus of an element into to be a nucleus of different or a new element. Okay, here now, the element X will emit helium here, which is alpha. Then it will be changed into what? A different element that we call it, for example, here what? Element Y. Okay, now the new element, which is Y, or the new nucleus that is Y, what will be its atomic mass and atomic number here? How do we know? We need to know in nuclear equations. This is now a nuclear equation. In nuclear equations, when we write them, we need to know that atomic mass is conserved. That means the sum of atomic mass on the left of the reaction should equal the atomic mass of the right side of the reaction. As you see, atomic mass here on the left of the reaction is 10. So that means the atomic mass here, it has to be also what? 10. So that means this is 4, so this one has to be 6. Why? Because they have to be 10 on the left side of the reaction and 10 on the right side of the reaction. This is for atomic mass. And also for atomic number, it's also what? The same. So here is, as you see, 6 here. So this one has to be 2. And what should I write here as atomic number? I should write what? 4. Since here it's going to be 6 on the right and 6 on the left. So that means if an element emits alpha, as you see, what will happen for the element atomic mass and atomic number? Look, the atomic mass will be decreased by 4 when it emits alpha. And the atomic number, it will be decreased by 2. It will be decreased by 2. So you understand now what is conserved in nuclear equations, and you understand what happens when an element or a nucleus emits alpha. Okay, this is now for alpha. What about what? Beta. What happens now when an element emits what? Beta. So that means when there is beta decay, what happens? Okay, we'll take as same, for example, here, X element X that has here 10 and here is what? 6 here. And this element now emits beta. What will happen for it? As we know, beta, it can be written like what? Like an electron with negative here and 0 here. So that means it's going to be like electron, and here is -1 and here is 0. This is now beta. And this now, this element which is X, when it emits beta, it will be changed into a new element. This element is, for example, what? Y. Okay, now, and this element that is Y, what will happen for its atomic mass and what will happen for its atomic number? So based on conservation of mass number and atomic number, we can see what will be the numbers here. So as you see here, this is 10 on the left side of the equation. So that means on the right side of the equation, also the atomic mass has to be 10. So since here is 0, so this number that has to be here, it has to be exactly what? It has to be 10. It has to be 10. So when I add now these ones, as you see, which is the atomic mass, it equals to the atomic mass of the left side of the equation. Okay, what about the atomic number? It's the same. The atomic number here is 6, as you see. And here now, this is -1. So what should I write here? As long as it's 6 on the left, that means on the right, it has to be 6 as well. -1 plus what now will give me 6 here? It has to be with what? It has to be 7. Why 7? Why 7 here, Shabab? Because now 7 plus -1 will give you what? Exactly 6. So that means in this case now, the equation is balanced. Atomic mass left side, right side are the same. Atomic number left side and right side, they are what? The same. But look here now what happens. As we see, when a nucleus emits beta, this is now, as we know, this is what? Beta. What happens for the atomic mass and what happens for the atomic number? So what happens to the atomic mass? It remains as it is. So 10 remains 10. So there is no change on the mass of an atom when it emits what? Beta. Okay, what about atomic number? The atomic number will increase by 1. The atomic number will increase by 1. Okay, why? How does, when it emits rays, when this nucleus emits rays, how do its atomic number increase by 1? So there is nothing went inside the nucleus. So that means what happened now? So what happened exactly, and you need to understand it by this way, that this number now, which is atomic number, it represents number of protons. We are talking about now, in these reactions, Shabab, we are talking about nucleus and what is inside the nucleus. So that means here, in these reactions, we are not talking about electrons. We are talking about protons and neutrons that are inside the nucleus. So we are not talking about electrons. So this here, which is the atomic mass here, which is 6 in this question, it means a number of atomic, it's the atomic number. And what is the atomic number? It is the number of protons. Is the number of what? Of protons. And the 10 that is here, is number of what? Protons and neutrons. Okay, now I want to say something now. What happens if one neutron is changed into proton? One neutron is changed into proton. And this happens when a nucleus emits beta. So one neutron is changed into what? Into proton. So in this case now, when one neutron is changed into proton, into what? Into proton. What will happen to the atomic mass and the atomic number? So look, here in the question, 10 is the atomic mass. That means number of protons and neutrons. And 6 here is the atomic number, which it represents number of protons here. Okay, now when one proton is changed into, when one neutron is changed into proton, what will happen for the atomic mass? When one neutron is changed into proton, that means the total number of protons and neutrons will not be changed. They remain 10. Because now one of the neutrons just changed to be proton. So that means the sum is still the same, which is 10. So a neutron is changed to proton, no change in the atomic mass. But will there is a change in atomic number? Yes. Why? Because the atomic number now, it means number of protons in this case. And number of protons will increase by 1. So when number of protons increase by 1, that means the atomic mass, the atomic number will increase by 1. That's why it becomes here what? 7. So that means here it was 6, then it becomes here 7 because 1 neutron is changed into proton. And as we know, in this equation here, this neutron is 1 in atomic, this neutron is 1 in the atomic mass, but it's 0 in the atomic number. So when it is changed into proton, the proton, as you know, is 1 here and 1 here. So in this case now, this neutron, when it is changed into proton, it will emit what? Beta. And beta, as we know, is electron here, -1 here, and here is 0, plus something we call it anti-neutrino, which is like V, and here is 0, 0. So in this case now, if we balance this equation, now, what will we get? As we see, the number here up, I'm going to use this color red. So here, as you see, on the left of the equation, there is 1 atomic mass, and here, all of it, just 1 atomic mass. So that means it's balanced for the atomic mass. Okay, what about atomic number? Here is 0 atomic number, and here is now, if you add these ones, 1 plus -1 plus 0, it's going to give you also what? 0 atomic number. So again, when an element emits beta, there will be no change in the atomic mass, but the atomic number will increase by 1. Okay, why the atomic number will increase by 1? Because 1 neutron inside that nucleus will be changed into proton. When it is changed into proton, there will be no change in the atomic mass, but the atomic number will increase by 1. And when neutron is changed into proton, as we said, it will emit beta and anti-neutrino. So in this case, the equation can be written this way for the change of neutron into proton that happens due to emitting beta ray. Okay, now we go to the next one here now. What about gamma? What about gamma here? Gamma, first, we said it is neutral. That means it's not positive and it's not what? Negative. And when a nucleus emits gamma, there will be no change in the atomic mass or atomic number, just a change in the energy itself. So if I have X and here is 10 and here is 6 and an element, when it emits gamma, it will remain as it is. So the element will remain as it is, just they'll be changed what? In or on the energy inside. So you understand now types of radioactive or types of nuclear radiations, which is alpha, gamma, beta, and understand when does they happen and what, I mean, yes, when they are happen, and we understand the difference between each one. Okay, and we understand here that a neutron can be changed into proton, and in this case, it will emit beta. Okay, just we had here one more note here, that as neutron can be changed into proton, also the proton can be changed into neutron. The proton, which is 1, 1, it can be changed into what? Neutron, which is 1 here, atomic mass and 0 atomic number. But in this case, when proton is changed into neutron, what will be emitted? Will it be gamma or alpha or beta? No, it's what will be emitted is a particle that is exactly similar to the electron, but it's what? It's positive instead of negative, and also plus what? Neutrino, which is what? V here, 0, 0, but it's not mentioned. So here now, proton, as we know, it can be changed into what? Into neutron, and here what will emit is something we call it positron. And positron is similar to beta exactly, but positive. So we call it positive beta, or we call it what? Positron. and it is the same mass of electron but different charge. Okay, we go now to another point, which is half-life. But we need to understand also that in general, the energy that bonds nuclear energy or bonds the energy, the nucleus as it is, it can be calculated by here, which is what? mc squared. What is this formula now? Energy equals m times c squared. That means now it equals the mass times the speed of light squared. Imagine we multiply now mass times the speed of light. We know the speed of light is 3 times 10 to the power of 8. If you multiply the square, you get the amount of energy that is combined with nuclear reactions. It's very big. It's very big, very huge. And it's only nuclear plants that can produce this power in order to start the reactions. And also they'll be given a huge amount of power, and it can be used for either peace purposes or for weapons. Okay, now last point for the lesson of today, which is half-life. What does it mean, half-life? So when radioactive element or nucleus emits radiations, its mass will decrease. So when the mass in some cases decreases, it decreases in a system, we call it what? Half-life. So what is half-life? Half-life means if I have a mass here, this is a mass of a nucleus that is, for example, 32 grams. If I tell you the half-life of it is, for example, 4 days, What does that mean? The half-life of a nucleus is 4 days or 5 days or years or hours. What does that mean? That means here, after 4 days, only half of this mass will be there. Only half of it will be there, and half of it will be what? Radiated. That means it will be missed, will be left. So here now, in this case, after 4 days, what will happen for this mass? After 4 days, it's going to be half of this number, which is what? 16. Okay, after 4 days again, so that means this is for 4 days. And after another 4 days, what will happen? This 16 will be what? Will be 8. Will be 8. And after also 4 days, it's going to be 4. And after 4 days, it's going to be 2. And like this. So that means half-life means with this period, just half of that mass will be left. Just so that means you can use it now. So as you see, if the element starts by 32 grams, after 4 days, it's going to be 16. That means after 8 days, it's going to be 8. That means now after 12 days, it's going to be what? 4. So that means we deal with it like after this period, which is half-life, its mass reduced by half, by half, by half. That's it for this part of physics. You can solve them the questions later. Thank you.